Hi everyone and welcome to lesson 2 from topic 14. In lesson 1 we just did a very brief overview of how to read scatter plots. Today we're doing a dive on how to build scatter plots. Oops, my sound is off, sorry.
Scuba divers wear wetsuits to maintain a comfortable body temperature as they dive. The table shows the temperature of the water and the thickness of a comfortable wetsuit. Step 1. Draw a coordinate grid. All of the data are positive, so you can just use the first quadrant of the coordinate plane.
Okay, so if we were asked to draw a scatter plot with this data, we need to look to see kind of where our numbers are. And the computer just said all of the data are positive. So there aren't any negative numbers here, which means that if we were to graph this and maybe draw our X and Y axis in the middle, we're giving room for negative numbers on these 3 quadrants. So we can just use this top quadrant. We don't have to worry about drawing the other 3 quadrants in our plane. So remember, a quadrant is just one section of the coordinate plane. So this is the positive quadrant. So that's what this is. And they're only going to use that one because we only have positive numbers here.
Step 2. Assign labels to the axes. Let the horizontal axis represent the temperature of the water in degrees Fahrenheit. Let the vertical axis represent the thickness of a wetsuit in millimeters.
All right, so just like with regular graphing, you want your x-axis to be the independent variable and this to be the dependent variable. So this is the one that's measurable, that is steady, and this is the one that varies.
Step 3. Determine a scale for the horizontal axis. The temperatures listed range from 33 degrees Fahrenheit to 80 degrees Fahrenheit. So consider a range of 0 degrees Fahrenheit to 100 degrees Fahrenheit. Set the increment so that you can make sense of the data once they have been graphed.
Okay.
Use an increment of 10 degrees.
So this is saying you're not going to want to make this first line 1, 2, 3, 4, 5, 6, and so on, because you're going to need to go all the way out to 80, and your graph is going to be ginormous. So instead, you want to look and see, okay, what's my biggest number and what's my smallest number? And here, the biggest number is 80 and the smallest number is 33. So we need to make sure that both an 80 and a 33 can fit on our coordinate plane. And that means we're probably not going to be able to count by ones. So in this situation, they chose tens. You could have chosen fives, you could have chosen 7, you could have chosen 8, anything at all. But typically we choose fives or tens or twos. But that's just normal. There's no rule saying you have to do one or the other. And in this case, they chose 10. And they're just saying make sure that when you choose these numbers, you can easily say, okay, 76 would be like right here, and 69 would be right before the 70. So you know that you can kind of visualize where your coordinates are going to go. Let's see the next label.
Step 4. Determine a scale for the vertical axis. The scuba suit thicknesses listed range from 1 6/10 millimeters to 9 5/10 millimeters, so consider a range of 0 millimeters to 10 millimeters. Use an increment of 1 millimeter.
So note that we did not need to use the same increments on both the x and the y axes. We used counting by ones on the y and counting by tens on the x's. That's totally fine, but that's why it's super important to label your axes. So that way the readers, whoever's looking at your graph, knows what we're looking at here. Does this mean 1, 1 or does this mean 10, 1? and so on and so forth.
Step 5. Graph each ordered pair.
All right, so note that none of these are in, this is not a straight line graph, it's a scatter plot. So there are going to be various plots or various scattering points all around this coordinate plane. And this would be a completed scatter plot for this data. Okay, so that's how we're doing this. Let's jump into our first example. So for this example, they already gave us the graph and they gave us the increments. So that's a handy thing to have. It looks like everything is in increments of 1. This is the fiber and this is the protein. And you know, I skipped over reading the example. So it says the table shows nutritional values per serving for various foods. Drag the points to make a scatter plot of the data. All right, so let's look at the first one. We've got fiber and protein for an apple. So fiber is 5, protein is 1. So let's start with, ooh, can I grab that? There we go. Fiber is 5, protein is 1. Oatmeal is 3, 3. So 3, 3. Kale, fiber is 3, protein is 2. Fiber is 3, protein is 2. Chicken is fiber is 0, protein is 9. When you're doing scatter plots, don't be afraid if you get one that's crazy off the regular chart. That's totally fine. 1, 6, 9, 7. I'm on squash, which is 0, 2. 0 fiber, 2 protein. Carrots are 0, 0. 7 grain bread is 2 grams of fiber, 3 grams of protein. And brown rice is 4 and 5, 4 and 5. All right, I'll pull this up just so we can double check. That's pretty much what we came up with. Looks pretty similar. And that means it's your turn to try it. So graph this on your, or in your student companion book. All right, so your table or your graph should look something like this. Almost looks like you could draw Texas out of it by drawing around it like that. Okay, so that's your nutrition and seafood example. Let's move on to part 2. Okay, part 2 is not coming up for me, but we can still do the got it in your book. So it just says the table shows the worldwide ticket revenues of the top grossing movies for several years. Make a scatter plot to represent the data. So we need the year and the total revenue in billions of dollars. So let me grab this. Okay, so this one, the only difference is they're not giving us the chart. So first of all, do we have any negative numbers? Nope. So we only need the positive axis or the positive quadrant. Okay, so this is 0, 0. And we need the year and the money. Well, year is going to be our constant. So this is going to be the year. And this is going to be money. And now we need to look at our increments. So we have 2003 to 2010. So maybe we'll make this 2000. So this will be 2000. And we'll go up by tens. 2000, or no, not by tens, by ones. 2001, 2002, 2003, 2004. Actually, I should make this 2000. This 2001. this 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. And then this I need to make between 9.2 and 10.6. So I can actually make this 9, and I can do, or actually make this 9. I'll make that one 9. Maybe I'll make this 9.1. And then this is 9.2, 9.3, 9.4, 9.5, 9.6, 9.7, 9.8. Oh, this is not getting me close enough to 10.6. So maybe I need to make it 9.2s. So I'll make that, this is 0, 0 is going to be 9. So this will be 9.2, 9.4, 9.6, 9.8. This would be 10. And this would be 10.2, this would be 10.4, and this would be 10.6. And that would get us all the way through all of our data. This would be up here at 11. Okay, so then we just need to graph our points. So let's do that. So 2003, 9.2. So 2003 is 9.2. 2004 is 9.4. 2005 is 8.8. Ooh, I didn't see that 8, so that needs to be way lower. That's probably closer down here. 2006 is 9.2. 2007 is 9.7, 9.7. 2008 is 9.6. 2009 is 10.6. And 2010 is 10.6. Okay, so it's not a very pretty graph, but yours will look nicer because you're not doing it on a computer. All right, so let me pull up, oh, I couldn't pull this up. So let's go to part 3, see if part 3 will open for us. Okay, part 3 is not opening either, so we'll just stick with our Got It book here. Again, making a scatter plot. So actually, why don't you try this one on your own? Go ahead and try this one and I'll pull up the answer key. I'm leaving the video recording while I'm looking for the answer key so that way you can keep working. Okay, here's the answer key for part 3. How does your graph compare? The year opened is the X, the ridership per mile. What is that? Ridership per mile? Oh, of US subway systems. Okay. And then we've got this in increments of 1,000. You could have chosen something else. That's totally fine. And then the years, they started with 1850 and went to 2000. Okay, so yours might look different, but just make sure the coordinates are in the right spot and then you're good to go. Okay, so we're actually going to skip the close and check today, but if you would like to do it, you can. These are the answers for it. And then I'll see you over in lesson 3 very soon.